So like Fareed said, I'm Brandon Ramirez. I'm with a team called The Graph, and we're building a layer 2 protocol for querying public blockchain data. And today I'm going to talk to you a little bit about our progress in designing this query layer for Web3. So before we get into the design of the protocol, I kind of want to talk about what the problem is that we're trying to solve. And like all things on the internet, it kind of starts and ends with cats. So CryptoKitties is like a great dApp example because it's one of the few ones that like tried to hit scale and failed. And one of the problems that they had of doing everything on blockchain is that they've got millions or over 1 million CryptoKitties minted at the time that I made this deck. And in the application, they want to do these queries like query for kitties sorted by time or sorted by these different attributes. But that's not the way that they're stored on the underlying blockchain. And so as many of you guys probably know in the audience, this is a pretty technical crowd. What you would usually do for something like this is use a database index. And so that's exactly what most apps are doing today. They're using like a SQL database or some other database and taking advantage of like the native indexing capabilities of that database, which is fine. But the problem with this is that like all that infrastructure is running on a centralized AWS cloud or Google Cloud or whatever. So it's not really fulfilling the dream of like decentralized applications. I'll note that the dApps that aren't doing something like this are usually doing something like this locally on the user's machine, and the UX is terrible, right? The user has to like sync a bunch of events from the blockchain just to do something really simple in the app. So this is problematic because for those of us that believe in a Web3 stack that's fully decentralized, like this is falling short of the vision, right? It's creating single points of failure, and both in terms of infrastructure, but also economics, right? If a business shuts down, then the app stops working. And it's incentive incompatible for a lot of developers and a lot of projects, right? Like a team like Augur doesn't want to spend or pay for DevOps costs for the lifetime of the project. They want to be able to ship something usable to the community and then be able to walk away once that protocol and that application is self-sustaining. So like I said before, we're designing a decentralized query layer for dApps to mitigate this problem. And I'm not going to go through all the properties on this list that we're shooting for, but I will touch on the first one, which is data as an interoperability layer. At The Graph, we really believe this is one of the core promises of blockchain, that Web 2.0 was about proprietary APIs that were cloud-based. And we think that blockchains are going to enable this new paradigm where applications and developers interact with the common substrate, which is data, and that's the interoperability layer. And that's what we're hoping to kind of take blockchain and crypto that like final 100 yards to get there. So before I get into like our protocol design, just as like kind of a straw man, I want to like go through like what maybe a naive design would look like. So I kind of took the same infrastructure from a couple slides ago, and I just put it into a query node. So that's kind of what you're seeing in the top left. And we put in a decentralized network, and like, let's say you can pay for the queries with micropayments and problem solved, right? Well, not really. So I guess you could improve upon it a little bit, and you could like throw some like pseudo random verification. Maybe X% of the query responses need to get validated on chain. That's maybe better than nothing, but this falls dramatically short, right? For one, validating that many queries just consistently is going to be extremely expensive. Each of these data sets is different, so that the actual cost to a verifier of like validating these query responses would be pretty high. You're not really getting that much of an economic security margin, right? Your economic security margin is pretty low. Does everyone know what that term means generally? So economic security margin is how much an attacker or participant in the system would have to spend to lie to you in the context of the protocol, right? So if a query node, for instance, stakes $10,000 worth of ETH or graph tokens, and that's what they're going to get have slashed if they provide you an incorrect response, then your economic security margin is 10,000 ETH. And that's important as you're designing your system because for different use cases, like if your dApp is an exchange or it's going to cause users to make decisions that are economically significant, then you want to know like how much of a guarantee you have that the data you're working with is correct. So let's move into the actual design. So this is the working architecture of our graph node. This isn't the entire system, but we'll start here. And so I'm going to kind of take you through the whole loop. So at the top, you see that we have the DApp. And it's kind of a CQRS pattern for anyone that's familiar with that. So transactions are going to the Ethereum blockchain and to the smart contracts. Those smart contracts are emitting events, which the graph node, our query node, event sources inside of a WASM runtime. That's the mapping, so it's a deterministic ETL process. In turn, the data that's the output of that ETL is indexed, and it's added to this, what we call an index chain. And I'll touch on that more in the next slide. And then we expose that back to the DApp through like a GraphQL API is what we support today, but in the future it could be any number of query languages. And what I'll note here is the index chains, well, I'll touch on it here actually. So the index chains are basically layer 2 blockchains where the root hash of a Merkleized database index is committed to each block in the index chain. And so already your economic security margin is getting a lot higher because instead of just one query node kind of telling you like, oh yeah, this is the right result, now you have the guarantee of every query node in the system that's formed consensus around this index chain. So like if you have 10 query nodes, then your economic security margin is like 10x what it was in the last construction. The other nice thing about this is that you no longer have to choose, like make a trade-off between choosing a query node for the economic security margin, like the amount that they've staked, versus maybe other things like their latency or their performance characteristics or proximity to you, right? Like if you had to make that trade-off, you might not end up with an optimal UX, but in this way, like you can get a proof that the data you're getting is correct and has the economic security margin of query nodes that are distributed across the globe, while choosing a query node to give you that data that's maybe has like other characteristics that you're interested in looking for. And so these are a bunch of properties of like our Merkleized database indexes. I'm not going to go in depth into too many of these, but if you want to like dive into that during Q&A, I'm happy to. So real quick, the experience of building the subgraph, that's what we call the data sets that we index on the graph. They're kind of like these domain-specific data sets, right? So you might have like a subgraph for CryptoKitties, a subgraph for 0x. The definition of those subgraphs are in what's called a subgraph manifest, where you define your schema, you register mappings, it's stored on IPFS, and the hash of that kind of uniquely identifies your data set, right? And so that's going to uniquely identify what you're querying in the network. And like I said, we can query it with GraphQL today, but in the future, we'll support more query languages. So before I get into the query processing workflow, I want to talk a little bit about market discovery, right? Because we're trying to create an efficient marketplace for querying public blockchain data, right? It's not enough that we have the technical capacity to do it. We want to make sure that there's actually a robust network of query nodes that feel incentivized to provide this service in a verifiable way to the network. And so an important part of that is market discovery, right? Like how does a query node even know that the CryptoKitties data set is valuable to index or that the 0x data set is valuable to index? Chances are that they're not going to have like domain-specific knowledge of every DApp in the universe, right? So we need to have a participant in the network that does have that kind of private knowledge that can signal to the rest of the network, hey, this data set's going to be valuable in the future, and I'm willing to stake money on that fact. And so that's what the curator is doing. So the curator signals in the staking contract for a particular data set, and curating successfully is going to entitle you to an annuity based on how successful that data set is in the future, measured by the query volume to that data set. That kind of overcomes the bootstrapping problem. After that bootstrapping happens, then like query nodes can look at actual volume on the network, right? They can look at like the actual transaction volume. Sorry, I'm just checking how I'm doing on time here. We're good. And so query node, when they're looking at like the marketplace, they're going to say like, okay, this 0x data set has a ton staked behind it. So maybe I'm going to sync that index chain, and I'm going to start validating on that index chain. The final participant I want to touch on, this is a construction called delegated staking, which like you might be familiar with from a lot of different protocols. But what this gives us the opportunity to do is get participation from a wider selection of token holders in the network, right? How can we avoid like speculators and like free riders in the network that are just holding the token to like hope that the work other people are doing in the network is going to like drive that token value up? Encouraging people to delegate stake, allows all tokens that are in the network to do work. And the way that we encourage that is a mechanism called participation adjusted inflation. I believe Doug from LivePeer was the first one that offered up that construction. And it's basically you set a target participation rate in the network, and the further you are away from that target participation rate, the higher the inflation is going to be, thereby diluting the holdings of users in the network that haven't staked the tokens. And those inflation rewards go to users that have staked the tokens and are doing work in the network. So the query processing, this is actually, believe it or not, a simplified diagram. The query processing is a little bit more complicated, but the things I want to draw your attention to here is that when the gateway nodes are querying the query nodes for these read operations, they're not just getting the data back, but they're also getting a Merkle proof back that proves that that data came from the index chain that the gateway node specified. They're also getting back an attestation, and so the attestation is something that we can use for like dispute resolution. And so these attestations are potentially valuable, right, to like a fisherman or to anyone else in the network, because if you successfully file a dispute against one of these query nodes that's malicious, then you can get a portion of their stake tokens as like part of your reward. The other thing I'll note here is that fishermen, in addition to verifying like attestations, they can also just look at the index chain directly, which is something that like naive construction didn't have, right? Like there's a huge difference between a fisherman just collecting query responses after the fact and saying like, okay, I'm going to like validate some like subset of these, and like hopefully with this like battleship approach, we can make the system safe. In this construction, the fisherman can a priori validate these index chains like in real time, and then if a DApp user comes on later, they can get that Merkle proof that the data came from this index chain, and it carries a lot more weight in the system. The other thing I want to point out is that curators and delegators, as I mentioned before, get a portion of the staking reward and potentially a portion of the query fees as well in the system. So these are kind of areas of active research for us. What I've kind of walked through already is like the design that we have so far. And so a huge part of what we want to do is we start prototyping like the fully decentralized version of the protocol. Is to kind of explore the trade-off space, right? Like I kind of gave a hand-wavy, explanation of why like the first like naive construction wouldn't work, and I think you can take that at a pretty good face value, but like there's a lot of different designs that are in that general space, and broadly speaking, the way that we kind of think of the trade-off space is like at one end you have high centralization and high performance, and at the other end you have like really, really high security, but like performance takes a big hit, and we want to figure out not only like what does that curve look like, is it the curve on the left, is it the curve on the right, but like what's the most tasteful trade-off that we can make as a layer 2 protocol to kind of deliver the most value to users at the greatest security. And maybe it's even something that we make tunable in the context of the protocol based on like the particular application. One other thing I'll say about these diagrams that like I don't hear talked about a lot is that like almost every step on these diagrams, except for like the Snarks and Starks proofs, is relying on some level of economic security, right? Like even using like Merkleized data structures and consensus, like Nakamoto consensus is still relying on economic security, right? Like you're relying on the fact that people can't like buy enough hashing power to like overcome the consensus mechanism. Proof of stake constructions also rely on like a level of economic security, right? That doesn't mean that it's bad. It just means like we need to be honest about like the trade-offs that we're willing to make in the system, and in some cases, we might want the stronger like cryptographic security of Starks or Snarks. But our intuition right now is that the right trade-off is going to be somewhere in like the Merkleized data structure and like and consensus space, and that's kind of the index chain construction that I explained earlier. So on the mechanism design side, there's a ton of parameters in the network that we need to tune, that we need to select, and I'm not going to go into each one of these, but I am going to, there was a question in the previous talk about like how to set some of these parameters. I think it was someone sitting over there. And so I'll kind of give my framework for how I think about these things. I put them into 4 broad buckets. So I think you can have these parameters set at the network level, right? Like it can be fixed in the protocol, and it's something that can only be changed through like a hard fork in the protocol. You can have them set as like a variable value, and so that's similar to like the inflation that's determined by like the participation rate. You can have them set through free market mechanisms, and so that's like you can kind of think like how live peer, for example, only allows 15 or 20 or X validators, and like people are competing to stake enough tokens to be in like the active validator set. Like that's kind of a free market mechanism, right? Like you're not setting at the network level what the staking amount should be. It's kind of this competition that's setting the value. I actually think that's the most desirable way to set a parameter if you can set it, because it's kind of like the network reaching its own equilibrium, right? But it's not something that you can use for every single parameter in the network. And so that's kind of where governance comes in. I haven't heard this talked about a lot, but I kind of see governance as like a cop-out. Like it's kind of like a lot of projects that kind of like defer to governance and they'll say, okay, it's kind of saying like we don't know how to set this parameter. And that's not a bad thing. I think a lot of these parameters, like we're going to figure out how to set them through like empirical observation of like these live protocols. But that's kind of what you're saying, because like you're kicking the can down the road. You're saying that someone who's not us is going to figure out how to set this parameter, and maybe that's like the wisdom of the crowds. And so I think in some cases you don't have a choice, but I think it's important to call that out explicitly. And so an example of that would be like the target participation rate, right? Like again, going back to the live peer example, which I only keep bringing up because they're the only ones I know that have actually implemented this mechanism. In the past, like they chose 50% as the target participation rate. That wasn't like a scientific choice, right? Like that was kind of like a gut choice, and it's something that in the governance mechanisms of the protocol, people can change over time. One other thing I'll actually touch on that's kind of a tricky like active research question is doing forced errors for the index chains, and so. I've actually talked with a few protocols about this that are all kind of thinking about this. I haven't heard a good solution proposed for this, but going back to, let's see, is this not? So going back to this diagram, I kind of didn't stop on this, but like I have this fisherman here, right, and he's verifying the layer 2 index chains, and like you guys kind of just took it for granted that like this fisherman would exist and would feel incentivized based on like slashing malicious query nodes, but like in equilibrium, we would all expect for the network to not have malicious query nodes, right? Like if the query nodes learn that they're going to be slashed every time they do something malicious, like the equilibrium should be that no query node is committing malicious blocks to these index chains. So then the question is like, what's the incentive for the fishermen to keep validating these index chains in the network? So for other constructions that use fishermen for like different roles in the network, usually this is something where you rely on like what's called forced errors, right? Like you basically have in the protocol specification that there's some mechanism for creating a forced error, and then the fisherman will catch those forced errors and still get a reward. It's a little bit harder to do for layer 2 blockchains because like people are relying on these things to be correct. So this is an area of ongoing research for us, and if anyone has any novel thoughts on this, I'd be happy to talk to you afterwards. So I want to talk a little bit about our philosophy at the Graph and like how we've been approaching development. I've talked a lot about like our decentralized query protocol design, and I've talked a little bit about stuff that we've implemented so far. So I want to give like a quick update on where we're at now and like how we're approaching the path to decentralization. So we take the approach that we want to create value for developers as quickly as possible and on an ongoing basis. So each iteration that we do, we want to make sure that it's creating value for developers, and that's in contrast to like a more waterfall style approach where we say, we're not going to ship anything usable until the network can be fully decentralized. So what we've already open sourced and is on our GitHub, you can check it out at Graph Protocol, is an indexing node that has the WASM runtimes, the deterministic ETL, can listen to Ethereum events. You can build a subgraph and you can like run that locally or deploy it yourself and like host it. What it doesn't have yet is like the P2P networking and like the consensus layer and some of these other incentive mechanisms built into it yet. So like right now it's something that you can run yourself and you trust it because you're running it. But on the path to decentralization, there's all these tactical opportunities where we can like start centralized and we can move to the fully decentralized network over time. And so like the very next step that we're going to do is we're launching a hosted service early next year. But then there's all these other dimensions as well. So like governance, for example, like it can start with this centralized multi-sig, but it can move to something where we're using DAOs to signal that small group of people, and then eventually it could just be the DAO itself that's making protocol decisions and like setting parameters. I'm not going to go into all of these, but like another one that I think is like pretty interesting is like you could have a centralized registry that either like logically centralized or like architecturally centralized, and you can move to like an overlay network over time and use like the node discovery of that network as a registry. And payment channels actually are also pretty interesting. Like you can do a hub and spoke payment channel topology, which is like what SpankChain has done, for example, to like be the first. I believe they were the first ones to actually launch a payment channel network on Ethereum. And they did that by making the really pragmatic choice that they weren't going to try and solve this like really difficult graph traversal problem that like the Raiden network is trying to solve and making good progress on. So that's just kind of like our philosophy in like moving to the decentralized network. Like create value first and like decentralize slowly. And this is further out. We haven't done a ton of thinking or active research here yet, but in the future we want to support multiple blockchains. We're deciding on like what the next layer 1 that we would support is. So if you're part of a layer 1 project, please talk to us. We're looking at what our story is going to be for like indexing specific shards or specific plasma side chains, as well as like indexing like private data that's maybe encrypted on chain. And that's it. Thank you guys very much.